So this is another example of using integration by parts to evaluate a particular integral. And so for this one, we have an indefinite integral. It's the indefinite integral of natural log squared dx. And so the first thing that we want to do here is recognize that natural log of x can be both integrated and it could be differentiated fairly easy here. And to go ahead and start us off here, the first thing that we want to note is that we could rewrite this particular integral this way. And so in that, we see that we have the product of two functions here where the function is the same. So what we want to do here is employ the integration by parts technique. And here, if we let one of these equal f and the other equal g prime, then we can come over here and figure out what f prime and g will be. So for that natural log of x here, and for here, let this be natural log of x dx. So we need to include this part along with that as well. If we take the derivative of natural log of x, it's just 1 over x dx. And if we do the integral of natural log of x, we actually end up getting x times natural log of x minus x. Now, some of you may be wondering how we get that. Well, I'm going to take a break here and actually show you how we do that, and then continue on to finish up this particular problem. All right, so we wonder how we get this. So if we're going to go from g prime to g, then we need to integrate. And so what that would mean here is that we need to figure out what this particular integral is first. And so in looking at that, we see that we have two things here. We have natural log of x and we have dx, and they're multiplied times each other. So here it would be easier to take the integral of dx, and if we did that, we would just get x. And if we took the derivative of natural log of x, we would just get 1 over x. So this is a prime candidate for the integration by parts technique again. So essentially, I knew this because I knew I needed to do integration by parts within integration by parts. Okay? And so in doing this here, we're going to select this to be our g prime and select natural log of x to be our f. And so when we come here and do this, we see natural log of x is 1 over x dx. G prime is dx. So if we integrate that, that would just be x. And using the formula, again, the integral of f g prime is equal to f times g minus the integral of g prime f. Excuse me, that was incorrect. It should be the integral of f prime g. So let's go ahead and put that there, f prime g, and we'll just slap on the dx here at the end. We know that f is natural log of x and g is x, so that would end up being x times natural log of x minus the integral of f prime, which is 1 over x, times g, which is just x, and we put the dx there. All of this is just 1. So if we do the integral of 1 times dx, we know that that just ends up giving us x. And of course, since we're doing an indefinite integral, it'll be the plus c at the end. And so for this particular problem, this is the part that we're worried about. The x natural log of x minus x. And so that's how we get this g right here. And so now we're going to clear this side example and continue on with integration by parts and finish up this particular problem. All right, so now that we've cleared up that side example, let's go here and complete the problem. So we know once again that we need to do the integral of f g prime, and that's going to equal the integral of f times g. Sorry, not the integral, we've already taken that, so I don't have to say that again. So it'll just be f times g minus the integral of f prime g. And we'll just put the dx at the end. So here that gives us fg would be x natural log of x minus x, all that times natural log of x. And then we're doing the integral of 1 over x dx, and then in the middle here, which is g, will be x natural log of x minus x. Okay. And so multiplying through here, we'll see we'll have x natural log squared of x minus natural log of x. When we clean up the function inside the integral here, we'll have natural log of x minus 1, all of that, dx. And so we're confronted with the situation here where we can split these two up and do integral of natural log of x by itself minus natural log of 1 by, the integral of natural log of x minus the integral of 1 dx. And so here for the first term, we already know what the integral of natural log of x is x natural log of x minus x. So we can just go ahead and write that. And that's minus all of this. So we want to make sure we take into account of that. And then minus the 1 dx part would just end up being x. And then of course, we will have our plus c on the end. So now it's just a matter of cleaning everything up. So here we have x natural log of x minus x natural log of x plus 2x. So here these two end up being a negative 2x, and then a minus a negative is positive. And last thing, we notice we have 2 x natural log of x's here. So we want to combine terms there. And we end up with our answer here. So to do the integral of natural log, or the square of natural log dx, it would just be this particular expression here, which is x times the square of natural log x minus 2x times natural log of x plus 2x plus c. This concludes this particular example. of using integration by parts to take the integral of the square of natural log.